Hello everyone, I am Shiv Prakash, a research scholar, Department of Political Engineering, IIT BHU, Varanasi. Let's start for the today's session. Today's session is discrete time Fourier transform, which is applicable on the discrete time signal. DT-FT, discrete time Fourier transform. The discrete time Fourier transform is when DT-FT is a form of a Fourier analysis that is applicable to a sequence of values. Is a form of a Fourier analysis that is applicable to a sequence of values, typically a function of time, typically a function of time, sequence which is the function of time. The DTFT is used to analyze the frequency content of a discrete signal. Like in continuous time, which there is a harmonics order, frequency content of a harmonics order. Analyze the frequency content discrete time signal. It transform a sequence of discrete time signal into a continuous function of frequency. into a continuous function of frequency, not a time. Suppose the DTFT of a sequence of xn is defined as discrete time Fourier transform of a sequence xn defined as x omega summation of n is equal to minus infinity to infinity, total summation of xn from minus infinity to plus infinity into multiplication of minus j omega n, where you know xn is the time sequence, discrete time signal. Xn is the discrete time signal, and ohm, also known as omega, upper omega, is the normalized angular frequency. Which is in radian per second. Same as omega. Okay. A discrete time signal is converted into frequency domain, but it is a continuous function of frequency. Is known as the discrete time for Fourier transform. Like in Fourier transform, there is a continuous signal converted into the frequency domain in continuous frequency domain. Same thing here for the discrete time signal, which is converted in the continuous function of the frequency. Or define the periodicity in the discrete time Fourier transform. Periodicity in the discrete time Fourier transform. The TTFT is always periodic in omega with a period of 2 pi. This means in frequency domain, omega plus 2 pi is the same as the x omega. Repeated signal occurs in the Fourier transform. This periodicity arises due to nature of the discrete time signal, which are inherently sample. The discrete time signal, it means this will be actually the sample signal. Okay, let's take some example to solve this, then you can understand better about the discrete time Fourier transform. Okay, I have taken an example of Fourier transform. Let an input of xn having discrete time Fourier transform of x e power j omega is equal to 1 minus e power j omega plus 2 e to power of minus 3 j omega. No means of this one. We pass through an LTI system. The frequency response of LTI system is already given. Yeah. Then you are asking about the output of the system. Okay. You know about the LTI system. There is an LTI system. If you give some input, it will give some output, process and output. In discrete time, this will be xn, this will be yn, this will be hn, which is the system transfer function hn. If you pass through LTI system xn, it means that there is some transfer function yxn process the input and gives some output of yn. But in the question is given as input. This is the input of this system, and this is the system Fourier transform. This is the input Fourier transform, and asking about the yn. Well, already there is already given in the Fourier transform. You have to calculate in the Fourier transform. First of all, you know about the convolution. If there is an time domain signal, if we given some input to LTI system, that this will be the convolution problem. The yn is the convolution of input and the system transfer function, the system time. It means if you want to find the output of this system, this will be the xn input convolution with the system function. But same thing if you do in the frequency domain, you know about the frequency domain convolution will be a multiplication. E power j omega, because of this is the discrete time Fourier discrete signal that I am using as e power j omega. This will be xn in place of n, you use the e power j omega. Same, this will be the multiplication of this one. Okay, hn is given, this one is the given in the question, this one also given in the question. Here we have to simply put the value of x e power j omega and h e power j omega, and then you simply multiply because of this signal present in the frequency domain. X e power j omega, it is given as 1 minus of e power minus j omega plus 2 e to power of minus 3 j omega. Written here I am writing is equal to x e power j omega, it will given in the question as 1 minus of e power minus j omega plus 2 e to power of minus 3j omega. Okay. H e power j omega is given 1 minus of half e to power of minus j 2 omega. 1 minus of half e to power of minus j 2 omega. It's also known as ohm in our electrical quantity. We have to multiply simply because of this function available in the frequency domain. Frequency domain, the convolution will be a multiplication. It will be 1 minus e to power of minus j omega plus 2 e to power of minus 3j omega. Then we have to multiply of minus half here, and this will be a minus of half e to power of, I written as 2j omega, minus of 2j omega, minus minus will be plus, this will be magnitude is half, and if you multiply these two, then power will be added because of both are the negative power. Then e to power of minus 3j omega, this will plus minus will be minus 2 into a half, it will be 1 into power will be added minus of 5j omega. This will be 1, then put the e to power of j minus, arranging this in the order of the power, then half e to power of minus 2j omega, then 3j omega, it will be 2 plus half, it will be 5 by 2 plus 5 by 2 e to power of minus of 3j omega, then the remaining is e power of minus 5. Then you can easily convert this one into time domain. Like inverse of dt of t. Yn 1 is del n, you know about this one, minus this is the time delay e power of something, same thing occurs in the time delay, it will be del, magnitude is 1, n, this is the minus some time delay, minus of 1, then this will be a minus of 1. Minus this will be half magnitude into del n minus 2 plus 5 by 2 del of n minus 3 minus of del n minus of 5. The answer. Okay. del n minus of del n minus 1 minus of del n minus of del n minus 1 minus of half del n minus 2 plus 5 by 2 n minus 3 minus del of n minus 5. Think this will be the correct answer. And the next question, discrete time signal is given as xn is equal to 1 2 3 0 minus 3 minus 2 and minus of 1. Is having a discrete time Fourier transform is given x e power j omega. Then they are asking about the value of integration of minus pi to pi summation of x e power j omega mod of the solution is square mod of dt of t square. It means xn is given 1 2 3 0 minus of 3 minus 2 minus of 1, and it's asking about the Fourier transform minus pi to pi mod of x e to power of j omega square d omega. You have to integrate this one magnitude of the Fourier transform square. It means this will be the periodic signal, same thing like power. Okay, a summation property, you know about summation property. Okay, simply add one this one all thing minus pi to pi Fourier transform square. Simply we have to taken as magnitude of this one will be simply taken as the summation problem, taken as the limit of this one pi, subtract minus upper limit to lower limit minus minus of pi by minus pi is the lower limit into remaining signal magnitude is there mod of something, then simply square this one and add up this one. So by summation property 1 square plus 2 square plus 3 square plus 0 plus minus of 3 square plus minus of 2 square, simply square the magnitude of the all and sum of the all thing. This will be a 2 pi by minus minus of pi 2 pi into this will be a 1 plus 4 plus 9 plus 9 plus 4 plus 1. 4 1 plus 4 is equal to 5, 9 plus 5 14, 14 plus 9 23 plus 4 27 plus 1 28. This will be 56 pi given in the answer is third one. Next question is given as xn be a discrete time sequence which is given as 1 2 3 0 minus 3 minus 2 minus 1, same thing as the previous question. Simply it asking the discrete time Fourier transform of this function. This function is given x0 is 1. X0 is 1, it means this is the origin. In place of arrow is given in the value x0 is the 1. It means x0 is 1, it means this will be the x1, x2, x3, x4, x5 and x6. For the discrete time Fourier transform, it will be summation of n is equal to minus infinity to plus infinity xn into e to power of minus j omega n, where xn is given as 1 2 3 0 minus of 3 minus 2 minus 1, and given x0 is 1, it means this is the origin. Total number is 7. Then we have to choose an as n is equal to 0 to n minus 1, 7 minus 1, length minus 1, it will be a 6, 0 to 6. Because there is a 0 is also a number, 0 to 6 is 7 point, 0 1 2 3 4 5 6, total 7. If you include the 0 and maximum is 6. Then if you find the x discrete Fourier transform of this function, summation of n is equal to 0 to 6 xn into e power of minus j omega n. If you put the n is equal to 0, then x0, x0 it means here also e power 0 something power 0 is value is 1, then this will be x0 only. If you put the x is equal to 1, then x1 e to power of minus j omega plus x2 e to power of minus j 2 omega plus x3 e to power of minus j 3 omega plus of x4 e to power of minus j 4 omega plus x5 e to power of minus j 5 omega plus x6 e to power of minus j 6 omega. For the value of all thing x0, x0 is 1, we can mention here x0, x1, x2, x3, x4, x5, x6. You can plot this thing in discrete time signal at 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1 is value is 2, double of this one 2, add 2, this is value of 3, add 3, this value is 0, add 4, this value is minus of 3, add 5, value is minus of 2, add 6, value is minus of 1. Signal looks like that in time domain. Same thing, put the value here, x0 value is 1 plus x1 is equal to 2, 2 e to power of minus j omega, x2 is 3 e to power of minus j 2 omega, x3 is 0, x3 value is 0, then this will be 0, x4 is minus of 3, so minus of 3 e to power of minus j 4 omega, minus x5 will be minus of 2, is minus of 2 is given, minus of j 5 omega, x6 is minus of 1 e to power of minus j 6 omega. This is the value of discrete time Fourier transform e to power of j omega here of given function in time domain. But in the question is asking about x e power j pi, in place of omega it given as value as pi. Then put the pi value in this discrete type Fourier transform, then find the value of e to power of j pi. In place of omega you have to put the value pi. Then 1 plus 2 e to power of minus j pi plus 3 e to power of minus j 2 pi, this will be 0, minus of 3 e to power of minus j 4 pi plus 2 e to power of minus j 5 pi minus of, sorry, this will be negative, minus of e to power of minus 6 j 6 pi. Okay, we have to calculate the all value. As the value are e power of minus j pi. Let's check. This will be 1. Okay, fine. Next one, 2 into e to power of minus j pi. Take it as 2 e to power minus j pi. It means e power theta. You know about the e power j theta. It is the cos theta plus j sin theta. Then break this thing, all of thing like that. 2 e to power minus of j pi, it means cos of minus j pi minus pi, cos minus theta, it will be cos theta, then cos of pi, so minus sine cos minus sine of minus theta is equal to minus of sine theta, then this will be minus of j sine pi plus 3, this will be cos of 2 pi minus j sine of 2 pi minus of 3 cos 4 pi minus of j sine 4 pi minus of 2 cos of 5 pi minus of j sine of 5 pi, then last one minus of cos 6 pi minus j sine 6 pi. You have to put the value of all thing. This will be 1, okay, plus this will be 2. What is the value of cos pi? Just I want to write here a signal for our reference. This is a sinusoidal signal started from 0, pi, 2 pi, 3 pi, dot 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 like that. This will be, you can say, sine omega t. If you take as a t, cos started from 90 degree, this will be like that. 0, this is the pi, 2 pi, 3 pi, like that. And you can see here sinusoidal signal at pi, 2 pi, 3 pi, all is the 0. It means the odd sine term is 0. All time sine term will be 0. Cos term, if there is odd, in the odds the value is minus of 1. In even, this value is plus of 1. For the odd pi, cos function will be negative minus of 1. For the even pi, cos value is plus 1. Then put the value according to this. This will be cos pi. Cos pi, it means odd pi value is minus of 1. This will be minus of 1. Minus, this will be 0. Sine bottom 0 plus 3. Cos 2 pi. 2 pi will be 1. Minus 0. Sine value 0. Minus of 3. Cos 4 pi. 4 pi is even. Even also 1. Minus sine term is 0. Minus of 2. Cos 5 pi. Negative term minus of 1. Sine term 0. Minus of 6 pi. 6 pi is even function. It will be 1. Sine term will be 0. I place this one. Remove. 1 of minus of 2 plus of 3 minus of 3 minus of 2 minus of 1. So plus of 2. You can say e to power of j pi is equal to 3 3 cancel out, 2 2 cancel out, 1 1 cancel out. This will be 0. Okay. Simply you can find the all of term related to discrete Fourier transform. After that you have to replace the omega value by the pi. Then after you use the complex form of sinusoidal signal, e power j theta is equal to cos theta plus j sin theta. Then after we put the value. Okay. Next question is given as xn is half power of n un and yn is given as x square of n. That is asking about the Fourier transform of yn at omega is equal to 0. Okay, yn is given as x square of n, where xn is given as half of square of un. First of all, find the yn. Put the value of, sorry, this will be the n, 1 by 2 to power of n un square. Okay, this will square term is there. It means power 2 to power of 2n u square of n. This is the unit step response un. If you square of this term, 1 square of 1 will be 1 only. Yes, sir, no need to worry about that. And by this thing, you can break this one like 1 by 2 square to power of n un, and this will be have 1 by 4 to power of n un. This is the yn. We have to find the Fourier transform for this yn. Okay, you can try to solve this one. How can you find the yn? Means y e to power of j, in place of ohms given as omega, I put in same thing omega here also. You know about this one. This will be n is equal to minus infinity to infinity yn e to power of minus j omega n. Put the value of yn here and find the value of discrete Fourier transform. Just try about that, then I will solve this one. Okay, let's try to solve this. Put the value of yn in this equation. Number first, yn is equal to, this will be summation of n is equal to minus infinity to infinity 1 by 4 to power of n un into e to power of minus of j omega n. Okay, There is given un unit step function. Step function will be available from 0 to infinity only. Then you can change the limit of summation n is equal to 0 to infinity 1 by 4 to power of n e to power of minus j omega n. This will be your y e power j omega. Then you have to solve by using a geometric series. By taking a common of for n, and you can also solve like they put the value of omega. It will ask you about the e power of j 0. It will asking in the question, it is asking about the e to power of j 0. It means put the value of 0 at the place of omega. Then this summation will be n is equal to 0 to infinity 1 by 4 to power of n at omega e to power of 0. Omega is equal to, if I put the value omega is equal to 0, then e power 0 value is 1. Then this function is this value only. And this will be, if you expand this one, then this will be 1 e power of 0, 1 by 4 e power of 0, 1 plus 1 by 4 plus square term 1 by 4 of square plus 1 by 4 to power of cube. All of thing is GP. You know about geometric means series. You know about in GP, this will summation of this one. It will be a or 1 minus of r, where a is starting point, r is ratio, common ratio. Common ratio in this same function is r is equal to 1 by 4 power of divided by 1 is equal to 1 by 4, and 1 is a is equal to 1 in this series. Then you can add y e to power of j 0 is equal to a is 1 divided by of 1 minus of r is equal to 1 by 4, and this will be 4 by 3 is your answer. Simple. Is asking about the xn is given half of power n un, and un is yn is given as x square of n. Now put the value as of xn in the function of yn, then we will get the 1 by 2 to power of 2n and un. It means 1 by 4 to power n un. After that you can solve this question by using 1 by alpha power n un, like that. Alpha, where is alpha is less than 1, greater than 0 and less than 1. Then have to use the GP series for finding the summation of all the things. Simple. I want to solve this question. Alpha power n un. Discrete Fourier transform of alpha power of n un. Xn is given as alpha power of n un, where alpha will be less than of 1. You know about this, the Fourier transform formula e to power of j omega, it will be equal to summation of n is equal to minus infinity to infinity xn e to power of minus of j omega n. This will be summation of n is equal to minus of infinity to plus infinity, xn is alpha power of n un and e to power of minus of j omega n. There is a function of un step response. You know about this one. The limit of the summation will be changed from 0 to infinity. Then this will be a 1 equal to 0 to infinity alpha power of n e to power of minus of j omega n. We can take as a common of n power n, then we will get the n is equal to 0 to infinity alpha e to power of minus of j omega whole to power of n e to power of j omega. Same thing, this function will be in GP. We can use directly summation property of this one will be a divided by 1 minus r. 1 minus r will equal to this one 1 divided by 1 minus of alpha e to power of minus j omega. This is the Fourier transform of the alpha power n un. If alpha is lesser than 1. If also alpha is greater than 1, then you simply use the formula a divided by r minus alpha. If alpha is greater than 1. Okay. Okay, let's try for the next question. Next question is given as, so consider the signal xn is 2 to power of n minus of n u of minus of n plus 2, and yn is given as 2 to power of minus of n plus 2 and u of n plus 1, where un is the unit step sequence. Sequence is given because of this is the discrete time signal. That's why sequence is given. Let x e power of j omega, e power of j omega is the Fourier transform of xn, and y power of y into e power of j omega is a discrete Fourier transform of yn. Then the value of the integral 1 divided by 2 pi integration of 0 to 2 pi for a time period x e to power of j omega into y e to power of minus j omega d omega. By looking this one, you can understand this will be looks like a central ordinate theorem. To know about this one, first of all find the Fourier transform of all of things. Then after you can apply. Xn is given, Xn is given as 2 to power of n minus of 1 u minus of n plus 2. Yn is given as 2 to power of minus of n plus 2 u of n plus 1. Is asking about this one. asking about 1 by 2 pi integration of for whole time period x e to power of j omega into y e to power of minus j omega into d omega. In this case, you see here, this is the multiplication up to function x and y, and this function will be available in the frequency domain. If frequency domain multiplication will be in time domain will be a convolution. Then first of all find the convolution of x and y signal. Then after you can then you can simply uh, find the discrete time Fourier transform. Then after you use the value of this one, all integration by using central ordinate theorem. No xn convolution of yn in time domain, frequency domain will be x e to power of j omega into y e to power of j omega. Let some function, another function is zn, which is the convolution of xn and yn. And discrete time Fourier transform of this one is dt ft of xn is z power of e power j omega is equal to x e to power of j omega into multiplication of this one y e to power of j omega. But in the question is asking about the e to power of minus j omega inverted form. Then you have to careful about that. To find this function, find the u of minus of n. Xn is okay, 2 to power of n minus of n, u of minus of n plus 2 is okay, yn 2 to power of minus of n plus 2 u to power u plus 1, okay. But there is a negative option in the question, then you have to find inverted in time domain. If you put the value of minus of n in place of n, then this will be a 2 to power of n plus 2 u of minus of n plus 1. And you know about the property of inverted property. If there is a yn discrete Fourier transform, discrete time Fourier transform of this one y e to power of j omega, and if you invert the time of this one, a Fourier transform of simply put the value of negative in place of omega, this will be minus of j omega. It means you have zn is equal to xn, in place of yn you use the y of minus of n. Okay, put the all value here. xn is equal to 2 to power of n minus of 1 u of minus n plus 2 convolution of y of minus of n, y minus n is equal to 2 to power of n plus 2 u of minus n plus 1. Use the convolution property. Know about the convolution in discrete time. Yn is equal to xn convolution of hn. This will be happening summation of k is equal to minus infinity to plus infinity hk into x n minus of k. Okay, this is the property only. Use this function to find the zn. Zn is equal to convolution of this one will be a summation of k is equal to minus infinity to infinity hk taken as the xn 2 to power of n minus 1. In place of n, we have to put the value of k. 2 to power of k minus of 1 u of minus of k plus 2 into xn here is yn, and yn is 2 to power of, in place of n you have to put the value n minus k, 2 to power of n minus k plus 2 u of minus of n minus minus plus of k plus 1. There is a k function only, uk plus 2 function, then u minus of n plus something. The blank page. You know about the this thing u of minus of n plus something like plus 5. This function is available from minus infinity to plus 5 because of this is minus of un. It means this is available from minus infinity to plus 5. This function will be available from minus k. K it means minus of infinity to 2 only, plus of 2 only, not infinity. Then according to this, we have to change the limit of the summation. Z done is equal to summation of k is equal to minus infinity to value of k 2 only. There is unit step function will be eliminated by putting the limit here 2 to power of k plus 1, sorry, k minus of 1 into 2 to power of n minus k plus 2 u. There is a n term also is there, you can't be replace this thing. For this one you have, there the base is same 2 2, then you can add power simply 2 to power of k minus 1 plus n minus k plus 2 and u of minus of n plus k plus of 1. This will be summation of k is equal to minus infinity to 2 to power of k will be cancelled out n plus 1 u of minus of n plus k plus 1. This is the convolution Zn. You know about this one. This will be multiplication of xn convolution of xn and y of minus of n. We know about the discrete time Fourier transform of this one, e power of j omega. This will be x e to power of j omega into y e to power of minus j omega. Sorry. After this one, use the central coordinate theorem. Central ordinate theorem. Regarding to this theorem, you can find directly value of origin in time domain. The origin is equal to, by using a frequency domain, 2 pi 0 to 2 pi frequency domain to convolution e power j omega. Frequency domain means discrete time Fourier transform. Fourier transform. And e to power of j omega is 1 by 2 pi integration of 0 to 2 pi. Z e power j omega is equal to x e to power of j omega into y e to power of minus j omega into d omega. In the question asking this value, you can say question is asking 1 by 2 pi integration of 0 to 2 pi x e to power j omega into y e to power minus j omega d omega. Here same thing, 1 by 2 pi 0 to 2 pi x e to power j omega into y e to power minus j omega d omega. For the finite by the center ordinate theorem, this value is equal to z0. This z in time domain signal. Put the value of n is equal to 0 in time domain signal. The zn, you know already, I have calculated zn by using a convolution of xn and y of minus of n. This value is summation of k is equal to minus infinity to 2 to power of n plus of 1 u minus of n plus k plus 1. Then put the value 0 at place of n. This function will be minus infinity to 2, 0 here, this will be 2 into u of 0 k plus 1. Now you can replace unit step response also. uk plus 1, uk plus 1 will be available from 0 to infinity, 1 to minus 1 to infinity. u k plus 1, yeah, you written as n. This will be available from minus of n to infinity. But our summation is minus infinity to 2 only. It means minus infinity is not, the function is 0, it will available from minus 1. Then you can choose the summation will be a k is equal to minus of 1 to 2, 2. Okay. All value is 2 from minus 1 to 2. You have to add. This value is minus of 1, 0, 1, 2. This value is 2, this value is 2, this value is 2, this value is 2. All value is 2, 2, 2. We have to add this one. 2 at minus of 1 plus 2 at 0 plus 2 at 1 plus 2 at 2. This will be 8. Z0 is equal to 8. And this one is equal to 1 by 2 pi integration of 0 to 2 pi x e to power of j omega into y e to power of minus j omega into d omega. This value equal to 8. You can repeat this question. I have to. In the question asking about the given as the xn and yn only. Xn is given, yn is given, and is asking about the 1 by 2 pi 0 to 2 pi x e to power j omega y e to power minus j omega. But if you here given is yn only, if you uh, solve convert this one in discrete time Fourier transform, this will be y e to power of j omega, not e to power of minus j omega. For finding e power of minus j omega, you have to choose y as minus of n. This discrete time Fourier transform, it will be e to power of minus j omega. Then you have to convert this one first of all of minus of n. Then after you take a convolution of xn into y of minus n. Because of this convolution in discrete time, Fourier transform happening as e power of j omega into y e to power of minus j omega. Okay, you can solve by using 1 by 2 pi integration of same thing also, but there is no need to solve like that. Simply this function same looks like a central ordinate theorem. By central ordinate theorem, it says a function, any function like a zn and function of a two convolution of two quantity like of xn, convolution of y of minus of n. Then if you convert this thing in discrete time Fourier transform, then you can say the at value of zn at 0 is equal to, by the center ordinate theorem you can solve easily, 0 to 2 pi x e to power of j omega into y e to power of minus j omega. This will be, you can use at vice versa if there is available in frequency domain is some quantity available in frequency domain x and y in frequency domain is available, then if you integrate like that, you will directly get the value of that function in place at 0. We will get the value of that function at 0. This is known as the central ordinate theorem. Find the central point of that function. Okay, process of this one only. Then by using convolution, we will get the zn. Then we use this one thing. Put the value of 0 at place of n, and we will get the answer. Okay, like that. Next question is here. Find the discrete time Fourier transform of xn is equal to 0.5 to power of n un by using a geometric mean series, GP series. Xn is given as 0.5 to power of n un. Then for the Fourier transform in discrete time is equal to e to power of j omega is equal to summation of n is equal to minus infinity to plus infinity xn e to power of minus j omega n. Xn is given as 0.5 to power of n un, 0.5 to power of n un into e to power of minus j omega n. Un function available from 0 to infinity. Summation will be changed from n is equal to 0 to infinity 0.5 to power of n e to power of minus j omega n. For this thing, summation n is equal to 0 to infinity, take a common power of my n e to power of minus j omega to power of n. We can expand this one. If I put the value of 0, n is equal to 0, this value is 0. Sorry, some something power 0 value is 1. Plus if the value put the 1, then this will be 0.5 e to power of minus j omega to power of 1 plus 0.5 e to power of minus j omega square plus 0.5 e to power of minus j omega, sorry, omega, this one omega, upper omega, power of 3 plus dot dot dot. You can say this thing is in GP, like in GP, geometric progress, there is a 1 plus r square plus r cube plus dot 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 to infinity, then summation of this signal will be a divided by of 1 minus r. A is equal to 1, then this will be 1 minus r when r should be between 0 to 1 only. It means less than 1. For this system, what is the r? R is equal to 0.5 to power of minus of j omega. Then what is the value of x e to power of j omega is equal to 1 divided by 1 minus r. R is 0.5 e to power of minus j omega. This is the answer for that question. Okay. The next question is given as the Fourier transform pair is given. This is the xn. This is the Fourier transform x j omega or e to power of j omega. Given where un denotes the unit step sequence, then the value of a is asking about the value of a, this a. Okay. Let's try to solve this question. Xn is given as xn is equal to 2 by 3 to power of n u of n plus 3 and x e to power of j omega, this one is given as a e to power of j 6 pi f divided by 1 minus 2 by 3 e to power of minus j 2 pi f. you have to solve this find transfer function discrete time Fourier transform of this one, discrete time Fourier transform of this one xn. Then after that you can compare to both signal. Then after you will get the value of a. Okay, let's try. First of all, find the function of what is this function. Okay, you know about the property. If there is xn, Fourier transform of this one is e to power of j omega. If there is any shifting in this, if there is any shifting in this process, in time domain, there is shifting also in frequency domain. Same shifting available is there. It means e to power of j n naught omega into x e to power of j omega. Okay, let's try. Let some function of fn is equal to 2 to power of 3 to power of n un. Okay, then Fourier transform of this one, you know, alpha power n un 1 divided by 1 minus alpha e to power j omega. Alpha is 2 pi by 3 e to power of minus j omega. Suppose in the function in it changes n plus 3 unit, then at place of the n you have to put the n plus 3 u of n plus 3. Fourier transform of this function, the shifted value is same exponential shifted as same value 3 omega divided by of 1 minus 2 by 3 to power 2 into e to power of j omega. Okay, but this same function is not yours function. Then you can break the power here 2 by 3 to power of 3 into 2 by 3 to power of n u n plus 3. Fourier transform of this function will be same e to power of j 3 omega divided by of 1 minus 2 pi by 3 e to power of minus j omega. You can say this 2 to power 3 power n u plus 3, this is the xn, and this value is shifted transferred to the right side. Then this way written as 2 by 3 to power of 3 into xn. Yeah, you can write same thing 2 by 3 to power of n u of n plus 3. Fourier transform of this one transfer to right side, this will be a 3 by 2 to power of 3 into e to power of j 3 omega divided by of 1 minus 2 by 3 to power e to power of minus of j. At place of omega you can put the value of 2 pi of f. Same thing here 2 pi f. Then you can say this will be 2 by 3 to power of n u n plus 3 Fourier transform of this one 3 by 2 to power of 3 into e to power of j 6 pi f divided by f 1 minus 2 by 3 into e to power of minus j 2 pi f. In the given question, this will be the same thing. You can compare here. To compare same thing, then we will get the value of a at place of this one. The question given as 2 by 3 2 by 3 power of n u n plus 3 discrete Fourier transform of this one is a into e to power of j 6 pi f divided by f 1 minus 2 by 3 e to power of minus j 2 pi f. There is only a matched to this one. Then you can say a is equal to 3 by 2 to power of 3. It means 27 by 8. This value is 3.375. Okay, fine. Next, simply how can you plot the magnitude and phase of the discrete time Fourier transform? For the any complex form, you know about any function is it will be like e power in j form. The magnitude, you know about the magnitude of this one is equal to a square plus b square, and phase it will be a tan inverse of b by a. For this system, xn is given as del n. First of all, find the Fourier transform of this one. Then x e to power of j omega is equal to summation of n is equal to minus infinity to infinity del n e to power of minus of j omega n. Know about the del function properties. Simply you have to put the value of 0 in place of n because of there is a n only. Then this value is e to power of minus j omega 0, value is 1. It means you can written as e power of j omega 1 plus j 0. The magnitude of this one m is equal to magnitude of e to power of j omega, oh sorry, x is equal to 1 angle theta tan inverse 0 by 1 is equal to 0. In this case, you can plot this one magnitude here, angle here. Magnitude of this one is 1. 1 it means simply a constant value minus infinity to plus infinity. angle is 0. There is no angle in this option because of there is only real term. Suppose if any delay provided in the question, any delay is provided in the system, then what happened in the phase and magnitude? Same thing I written as same example by some delay. Then how much phase it will be added in your system if there is any delay provided in the system, in the signal. Then discrete time Fourier transform of xn is equal to x e to power of j omega is equal to summation of know about all of the minus infinity to plus infinity xn e to power of minus j omega n is equal to summation of n is equal to minus infinity to infinity del of n plus k e to power of minus j omega n. In this case, you have to put the value of k in place of n minus of k, because of n plus k is equal to 0, n is equal to minus of k. And e to power of minus j omega minus k. Then you can say the discrete time Fourier transform of this one signal is equal to e to power of j omega k. Then what is the magnitude of this one? Magnitude same thing 1. What is the angle? Angle of this system is omega k. Because of this thing you can written as cos of omega k plus j sin omega k. You find the angle, this will be tan inverse sin omega k divided by of cos omega k. This will be a tan inverse of tan omega k. Tan inverse tan will be cancelled out, this will be only omega k. If you want to plot this thing in magnitude and phase plot, this will be the magnitude. Magnitude is 1, all is 1 from minus infinity to infinity, but angle is very with respect to the omega. This is omega plot, na? This is minus omega, so plus omega. Angle will value provide a linear phase, which is the slope of this function will be a k. It means any delay in your function, it provides the linear angle in your system. If you provide an LTI system, you put some delay in your system and passing through the LTI system, then the output of that system will be delay or linear, provide a linear delay in phase. This is the important part of phasing. Okay. There is a last question. I will take it. I just Evaluate the discrete Fourier transform of xn, which is given as 1, 2, 3, 2, 1, and origin at 3. Then find x e to power of j omega at is equal to 0. Same thing we apply, sorry, n is equal to minus infinity to infinity xn e to power of minus of j omega n. Xn is given from here to here. This is x0, x1, x2, x of minus of 1, x of minus of 2. It means this is given as n is equal to minus of 2 to plus 2 xn e to power of minus j omega n. Expand this all of thing, then we will get the x of minus of 2 e to power minus of j omega n. Sorry, you will put the 1 minus of 2 in place of n, then this will be a positive of j 2 omega plus x of minus of n e to power of j omega plus x0 e to power 0 is 1 plus x1 e to power of minus of j omega plus x2 e to power of minus of j 2 omega. X minus of 2 is given as 1. This will be e to power of j 2 omega plus e to power x minus 1 is 2 e to power of j omega plus x0 is 3 plus x1 is 2 e to power of minus of j omega, x2 is 1 e to power of minus of j 2 omega. This is a 3 plus, you can put this thing at a place 2 into e to power of j omega plus e to power of minus of j omega plus this thing is together e to power of j 2 omega plus e to power of minus j 2 omega. We have to simply multiply by 2 and divide by 2 here, same thing, multiply by 2, divide by 2 here. Then you know e power j theta plus e power minus j theta divided by 2 is equal to cos theta. 3 plus 4 cos omega plus 2 cos 2 omega. This will be x e to power of j omega. It asking about the omega is equal to 0. They put the value omega is equal to 0. It means 3 cos 0 is 1, cos 0 is 1. This is a 2. Total value is 9. This is the final answer of this question. Okay. Okay, everyone. I want to stop here and thank you. For the exam preparation, you have to revise all of things, especially for the signal questioning about the question, Laplace and jet transform. Then some question about the Fourier transform, Fourier series. Question is there. For the signal system book, there is a book about the signal system. open and I written here. You can follow this book. System open and risky. You can follow this book for the all understanding the signal system. Okay, thank you to all.